Hi students, welcome to MI Academy, and today in this video we are going to continue the grade 10 chapter 3, of the science, structure of matter, and today in this video we will study about metals, nonmetals, and metalloids. And chemical formula. If you have not still subscribed to MI Academy, then click the subscribe button, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. So if you all look at the above figure, as you all know, the elements colored in blue are metals. The elements indicated in brown are nonmetals, including noble gases. The elements indicated in light green around the steps have properties in between the metals and nonmetals. Therefore they are called metalloids. So first let's look at what are metals, and some of the examples of them. Of the elements identified so far, more than 80 are metals. In nature, these exist as native metals as well as compounds of metals. Metals such as silver and gold are found as native metals in nature, whereas many metals such as iron, aluminium, magnesium, and sodium exist as their compounds. Given below are some physical properties of metals. They have a metallic luster. Metallic luster means having a shiny surface. Sonorous, it gives a ringing sound when struck. Metals exist in solid state at room temperature. Only mercury is a liquid. Malleable, metals can be hammered into sheets. Ductile, they can be drawn into wires. Good conductors of heat and electricity. Generally have a high density. Chemical properties of metals. Metals form positive ions by losing electrons. They combine with oxygen to form basic oxides. The oxides, when dissolved in water, form basic solutions. So now let's look at some of the examples for metals. So first let's look at sodium metal. Sodium is a metallic element belonging to group 1 of the periodic table. It is a highly reactive element. It never exists as the native metal. Because of its high reactivity, it exists only as compounds. Sodium chloride is one of the main compound containing sodium, occurs in seawater. Sodium metal is stored in paraffin oil or kerosene, so that it does not come into contact with air. When sodium metal is taken out of paraffin oil, its luster disappears. The metal can easily be cut with a knife. The freshly cut surface gives a silvery luster, but it gets tarnished after some time. The physical properties of sodium metal are: it is a soft metal which can easily be cut with a knife. It floats on water because its density is less than that of water. It is a conductor of heat and electricity. Then the chemical properties of sodium metal are: sodium shows a high reactivity towards oxygen. It reacts rapidly with oxygen in air to form the oxide of the metal. Sodium metal also highly reacts with cold water, forming sodium hydroxide and hydrogen gas. It reacts violently with dilute acids and forms salt and hydrogen gas. So the uses of sodium metal are: production of sodium cyanide used in the extraction of gold and silver. Making sodium amalgam, which is used as a reducing agent in organic chemistry. Extraction of metals such as titanium and zirconium from their compounds. Production of indigo dye used to dye trouser materials, which is the denim. Using the production of street lamps with a yellow glow. So next let's look at magnesium. Magnesium is a light, reactive metal. It does not exist as the native metal in nature. In seawater it occurs as magnesium chloride. When exposed to air, magnesium tarnishes so its luster cannot be seen. But when cleaned with a sandpaper, the luster becomes visible. Physical properties of magnesium. It is a good conductor of heat and electricity. It has a higher density than that of water. Chemical properties of magnesium. When heated in air, magnesium burns with a bright white flame, giving white magnesium oxide. Magnesium does not react with cold water but reacts with hot water. As a result, it forms magnesium hydroxide and hydrogen gas. When the metal is strongly heated in steam, magnesium oxide and hydrogen gas are formed. Magnesium rapidly reacts with dilute acids and forms the corresponding magnesium salt and hydrogen gas. Gas. The uses of magnesium: by mixing magnesium with aluminium, an alloy called magnesium is produced. This alloy is strong and resistant to corrosion. It is used in aircraft industry and in making parts of automobiles. Production of medicines, example milk of magnesia. It is used as a metal that prevents corrosion of iron. Now let's discuss about nonmetals. Generally, nonmetals have properties opposite to those of metals. There are nonmetals which occur as native elements as well as compounds of other elements. Some nonmetals occur in solid state while some others exist in liquid and gaseous states. At room temperature carbon, sulfur, phosphorus, and iodine exist in the solid state. Bromine is a liquid at room temperature. Chlorine, fluorine, nitrogen, and oxygen are some nonmetals occurring in the gaseous state. Nonmetals do not have a metallic luster. They cannot be hammered into sheets or drawn into wires. Many nonmetals are brittle and are poor conductors of heat and electricity. However, graphite, a nonmetal, is a conductor of electricity. Nonmetals have a relatively low density, but the density of diamond is high. The chemical properties of nonmetals are: nonmetals form negative ions, anions. Many oxides formed by nonmetals with oxygen are acidic. Mostly these exist in the gaseous state. They easily dissolve in water and form acids. Some examples of nonmetallic elements are: first, let's look at nitrogen. Nitrogen exists as a free and diatomic gas in the atmosphere. About 78.1% by volume in the atmosphere is nitrogen gas. Nitrogen is also present as a component in animal and plant proteins. Nitrogen also exists as a constituent element in soil, air, and organic substances. Physical properties of nitrogen: it is colorless and odorless. It is lighter than air and is slightly soluble in water. Chemical properties of nitrogen: nitrogen is a non-supporter of combustion. It is a gas of very low reactivity. At high temperatures, nitrogen gas reacts with nonmetals such as oxygen, hydrogen, carbon, and silicon, as well as with metallic elements such as magnesium and aluminium. When sent through a strong electric arc, nitrogen combines with oxygen in the atmosphere to form unstable nitric oxide gas. The nitric oxide gas so formed reacts further with oxygen in air to form an acidic gas, nitrogen dioxide. During lightning, this process occurs naturally. Under special conditions, nitrogen gas reacts with hydrogen gas to form ammonia gas. Industrially, ammonia is manufactured by this method. Ammonia so prepared is used as a raw material to produce nitrogen, containing fertilizers and explosives. When heated, nitrogen gas reacts with metals like magnesium to form metal nitrides. Uses of nitrogen gas: nitrogen gas is used to produce ammonia in industrial scale, chemical fertilizers, and other nitrogen compounds. Since it is an inert gas, it is used to fill electric bulbs and thermometers. When making electronic devices, a nitrogen gas environment is used. When storing some substances, nitrogen is used as a blanketing gas. When packaging milk powder, nitrogen is used. Liquid nitrogen is used as a coolant. It is also used to fill vehicle tires. Next, let's look at sulfur. Sulfur is an element that exists in different forms in nature. Those forms are referred to as allotropes. Sulfur occurs in crystalline form as a yellow brittle solid, and in amorphous form as a white powder. In nature, it is found both as a native element as well as compounds like sulfates and sulfides. It is a constituent element in some amino acids found in the bodies of living beings. Sulfur clearly shows the properties of non-metals. The physical properties of sulfur are: it is a poor conductor of electricity. Sulfur is insoluble in water. It is slightly soluble in organic solvents and very soluble in carbon disulfide. Chemical properties of sulfur: sulfur burns with a blue flame in air and forms sulfur dioxide gas. When heated with sulfur, many metals form the metal sulfide. Uses of sulfur: sulfur is used to produce sulfuric acid, vulcanize rubber, and make calcium and magnesium sulfides, which are used to bleach wood pulp. It is also used to produce paints containing sulfides, solvents like carbon disulfide, sulfur dioxide gas, matches, crackers, and gunpowder. Sulfur is also used in the production of wine, beer, and medicines, and is used as a fungicide. Next, let's look at carbon. Carbon is a nonmetal element occurring in abundance. It occurs as carbon dioxide gas in the atmosphere, animal and plant tissues, all organic compounds, coal, petroleum products, and other hydrocarbons containing carbon. It is an element showing allotrope. Carbon has crystalline forms as well as amorphous forms. Crystalline carbons are diamond, graphite, fullerene. Amorphous carbons are charcoal, lamp soot, coal. Physical properties of carbon. Physical properties of carbon differ according to the allotropic form of carbon. Except diamond, the other forms of carbon are black in color and exit in the solid state. Their density is relatively low. But diamond is the form with highest density. Diamond is much valued because of its high refractive index and hardness. Diamond is a poor conductor of electricity. But graphite is a good conductor of electricity. Charcoal has the ability to absorb gases. Chemical properties of carbon. Carbon is an element of low reactivity. It combines with oxygen at very high temperatures, but does not react with substances like acids, bases, and chlorine. Amorphous forms like charcoal react chemically. When strongly heated and ignited, charcoal reacts with oxygen to form carbon dioxide. At high temperatures, carbon reacts with calcium oxide forming calcium carbide. Uses of carbon. Different allotropes of carbon has different uses. Some of the uses of carbon are given in the table. Amorphous carbon. Production of black color ink, vulcanizing rubber coal. A fuel graphite. Making pencils, making electrodes of electrochemical cells, used as a lubricant. Diamond. Making jewelry, cutting glass, and gems, used as pivots at points in machines that are subject to wear away. Charcoal. Absorbing gases, purification of water, carbon fibers, and carbon tubes. Used to produce goods reinforced by nanomaterials. Carbon fiber is very light and it is very strong. Now let's discuss about some of the metalloids. First let's discuss about silicon. Except oxygen, silicon is the most abundant element in the Earth's crust. As compounds, silicon occurs in both crystalline and amorphous forms. Quartz, sand, and gems such as emerald are crystalline silicon compounds. Clay is an amorphous silicon compound. The melting point of silicon is 1410 Celsius. Uses of silicon. Used in making transistors and diodes. Used in making solar cells. Used in making computer equipments. Next is boron. Pure boron occurs as a black, crystalline solid. It melts at 2200 Celsius. Its reactivity is relatively low. Therefore it does not react even if heated to high temperatures in air. At very high temperatures amorphous boron reacts with substances like oxygen, nitrogen, nitric acid, concentrated sulfuric acid, carbon, and sulfur to form the corresponding compounds. Uses of boron are used in welding metals, used in making cream, used in making glass that can be heated into a high temperature. Now let's look at acidic, basic, and amphoteric nature of oxides. An oxide is a chemical compound that combined element with oxygen. So if you look at this table you can identify that acidity of the oxides increases across the periodic table. Basicity of the oxides decreases across the periodic table. You can see that sodium oxide is strongly basic, then the next one magnesium oxide is weakly basic. From silicon to chlorine, the acidity of the oxides increases. Aluminium oxide shows both acidic and basic properties. Such oxides are called amphoteric oxides. Accordingly, from left to right of a period in the periodic table, the basicity of the oxides decreases and their acidity increases. Now we are going to discuss our last topic, that is chemical formula. Here we will be discussing on how to write chemical formulas. The main element for writing chemical formulas is valency. The combining ability of an atom of an element is known as the valency. The electrons present in the outermost energy level of an atom of an element are called valence electrons. But also some elements can have several valency. The number of valence electrons in an atom of an element is generally equal to its highest valency. The valency of an element is equal to the number of electrons lost from or gained by an atom of that element, or the number of pairs of electrons shared between the atoms during chemical combination. We know that chemical symbols are used to identify elements easily. Example: carbon C, calcium Ca, potassium K, sulfur S. For example, H2O is used to represent water, a compound consisting of 2 hydrogen atoms and 1 oxygen atom. This is called the chemical formula of water. If there is a number at the bottom of the symbol of an element in a chemical formula, it indicates the number of atoms of that element present in a molecule of the compound. If there is no such number, only one atom of that element is present in a molecule of that compound. For example, chemical formula of glucose is C6H12O6. This means that a glucose molecule comprises 6 carbon atoms, 12 hydrogen atom and 6 oxygen atoms. There are instances where the chemical formula does not represent a molecule. Table salt, known as sodium chloride, is such a compound. Solid sodium chloride does not contain discrete molecules. It is an ionic lattice composed of alternately arranged Na+ and Cl- ions. In the lattice Na+ and Cl- ions are present in the ratio of 1:1, so its formula is written as NaCl. Now let's discuss on how to write formula using valency. Valency of the elements from atomic numbers 1 to 20 is given in the below table. Hydrogen can lose 1. Helium 0. Lithium can lose 1. Beryllium can lose 2. Boron can lose 3. Carbon can lose 4. Nitrogen can gain 3. Oxygen can gain 2. Fluorine can gain 1. Neon 0. Sodium can lose 1. Magnesium can lose 2. Aluminium can lose 3. Silicon can lose 4. Phosphorus can lose 5, and also it can gain 3. Sulfur can lose 6, can gain 2. Chlorine can lose 7, can gain 1. Argon 0. Potassium can lose 1. Calcium can lose 2. So writing chemical formulas can be done in 2 steps. First step is writing the valencies of the 2 elements under them respectively. And the second step is exchanging the valencies of the 2 elements and writing them at the bottom end on the right hand side of the respective symbols. Example 1. Sodium chloride. So first we have to write the valency of the 2 elements, Na and Cl under them. Then exchange the valency of the 2 elements and writing them at the bottom end on the right hand side of the respective symbols. So the chemical formula is NaCl. Example 2. Calcium chloride. So first we have to write the valency of the 2 elements, Ca and Cl under them. That is 2 and 1. Then exchange the valency of the 2 elements and writing them at the bottom end on the right hand side of the respective symbols. So the chemical formula is CaCl2. Example 3. Sodium oxide. So first we have to write the valency of the 2 elements, Na and O under them. That is 1 and 2. Then exchange the valency of the 2 elements and writing them at the bottom end on the right hand side of the respective symbols. So the chemical formula is Na2O. Example 4. Calcium oxide. So first we have to write the valency of the 2 elements, Ca and O under them. That is 2 and 2. Then exchange the valency of the 2 elements and writing them at the bottom end on the right hand side of the respective symbols. So the chemical formula is Ca2O2. But we can simplify this formula and write it in its simplest form CaO. We can do this only if we can simplify them. Example 4. Magnesium nitride. So first we have to write the valency of the 2 elements, Mg and N under them. That is 2 and 3. Then exchange the valency of the 2 elements and writing them at the bottom end on the right hand side of the respective symbols. So the chemical formula is Mg3N2. So now let's see what are polyatomic ions. A polyatomic ions is an orderly arranged group of atoms of elements with a charge. Some common polyatomic ions are given in the below table. So you can see these are some compounds with different atoms containing a charge. So the valency of these are the charge of the compound. Ammonium. NH4 with a plus charge, so its valency is 1. Hydronium H3O with a plus charge, so its valency is 1. Nitrate NO3 with a minus charge, so its valency is 1. Hydrogen carbonate, bicarbonate, HCO3 with a minus charge, so its valency is 1. Hydroxide O with a minus charge, so its valency is 1. Permanganate MnO4 with a minus charge, so its valency is 1. Hydrogen sulfate, bisulfate, HSO4 with a minus charge, so its valency is 1. Chromate Cro4 with 2 minus charge, so its valency is 2. Dichromate Cr2O7 with 2- charge, so its valency is 2. Sulfate SO4 with 2- charge, so its valency is 2. Carbonate Co3 with 2- charge, so its valency is 2. Phosphate Po4 with 3- charge, so its valency is 3. Let's consider the formulae of the following as examples for compounds with polyatomic ions. Example 1. Sodium nitrate. So first we have to write the valency of Na plus 1 and NO3 minus 1. That is 1 and 1. Then exchange the valency and write them at the bottom end on the right hand side of the respective symbols. So the chemical formula is NaNO3. Example 2. Potassium carbonate. So first we have to write the valency of K plus 1 and CO3 minus 2. That is 1 and 2. Then exchange the valency and write them at the bottom end on the right hand side of the respective symbols. So the chemical formula is K2, CO3. Example 3. Magnesium nitrate. So first we have to write the valency of Mg plus 2 and NO3 minus 1. That is 2 and 1. Then exchange the valency and write them at the bottom end on the right hand side of the respective symbols. So the chemical formula is Mg, and NO3 is written within the brackets and outside of it 2 is mentioned. Example 4. Ammonium phosphate. So first we have to write the valency of NH4 plus 1 and PO4 minus 3. That is 1 and 3. Then exchange the valency and write them at the bottom end on the right hand side of the respective symbols. So the chemical formula is NH4, is written within the brackets and outside of it 3 is mentioned, and PO4. And we have come to the end of our video. We have finished discussing the chapter 3 of the grade 10 science. So please give a support to us by subscribing to MI Academy, and also please, like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn quickly and easily.